Welcome to another video where we will learn about abstraction. It is a third major concept of object-oriented programming, and this concept can be a little confusing and overwhelming, but hopefully this video will clear that up. I'm going to be dividing this video into two smaller parts just so it becomes easy to understand and you guys won't be overwhelmed, as there are a couple of important concepts to abstraction. This video will be on achieving partial to full abstraction via abstract classes, and the next video will be on interfaces, which is a way of achieving complete abstraction. Okay, what is abstraction? Well, easiest way you guys can think of abstraction is like an abstract of a paper or like a summary of a paper. It is where we define or give a very brief overview of what the paper will be about, and then we divide our paper into multiple sections where we go into details. It's a very similar concept that applies in programming as well. In abstraction, we just define the ideas rather than the implementation, meaning it is where we hide the implementation details. Let's do an example. Let's create an abstract class called shape. And to make a class an abstract, we just have this keyword called abstract, and this basically makes a class an abstract. Let's create a couple of properties for this. One would be, let's say, color, and the other we can say, when this shape was created. So we can have a date object from Java util package. So we can say date created. And let's create two constructors for this. One will take in a color, and the other will be an empty constructor. So let's do that. And here we can just set the date, so when the shape was created. So we can say this.create equals new date. This will basically tell us, okay, this is when the shape object was created. And let's do the same thing there. Let's also create the getters and setters for these properties. So we're going to create a getter and setter for color. And let's just do a getter for date, because we don't want to set the date again. So we'll do just a getter for date created. All right, let's test out the shape class. We're going to head over to main, and let's create a new object of shape. And we are going to get an error. If I hover over this, it says shape is abstract. It cannot be instantiated because abstract classes are meant to be used by regular classes. If I run this as well, we're going to see a compile time error. If I go back to the shape class and I remove this keyword abstract, I can now use it. So if I head over to main, I don't have this error anymore, and I can access all the properties such as date, get date created, or get color. So basically, we cannot create an object out of an abstract class directly. Their job is to only help construct regular classes by giving them ideas that they would want to work with or implement. So let's create a class that would use this abstract shape class. So before I do that, let me just make this abstract again. And let's create a new class called rectangle that would implement the shape class. So let's extend from shape. Now let's try using this rectangle class. Let's see how that would work. So instead of doing new shape, I'm going to do new rectangle. Now I don't have this error anymore. So if I now have access to all the methods from the shape class, so if I can even print it out. So I can do s.getDateCreated. I can even, let's say, set the color. So I can say, set color to blue, and also print that out. And let's run this. All right, there you go. So this object was created on this date and the color was blue. Even though I haven't implemented anything inside the rectangle class, I'm able to access or print out these properties or method. Why? Because I'm extending from the shape class. Since I'm extending from it, I'm able to access all of its properties and methods. All right, now the question is, why are we making the shape class abstract? Why can't we make this a regular class and just extend from it? Well, we can. If I go back to the shape class, I can just remove this abstract keyword, and I would still be able to use it. And if I go to main, if I run it, it would still work. However, the point of abstract classes is to give an idea. And let's say that idea is that every shape would need to calculate an area, perimeter, and number of sides it has. To do that, I would need to create an abstract method or define these abstract methods. Now, abstract methods have no implementation. The implementation is done by the classes that inherit these abstract classes. So let's create these three abstract methods. So to do that, we just have this abstract keyword, and we are going to have get area. Now I'm getting this error. Why? Because the class is not abstract. Only abstract classes can have abstract methods. So let's create two other abstract methods as well, which is get perimeter and number of sides. Now, if I go back to my rectangle class, I'm getting this error. And if I hover over this, it says implement these three methods, since I'm extending from abstract shape class and it has these three abstract methods: get area, get perimeter, and get number of sides. In order for me to implement the get area and get perimeter methods, I need to have width and height. So let's create those two properties. So we're gonna have width and height. And let's create a constructor as well. So we're going to say in order to construct a rectangle object, we need to have these two properties. We need to have width and we need to have height as well. Now we can implement the get area and get perimeter method. So to do the get area, we just need to multiply the width and the height. And to do the perimeter, we just add up all the sides. So we can just do 2 times width plus height. And for number of sides, we know rectangle has 4 sides, so let's just return 4. Actually, let's just make this an int, and let's go to shape, and we'll make this an int as well. All right, let's test this out. We're gonna head over to main, and let me just rename this to rectangle. And now we're seeing this error because we need to supply these two parameters, width and height. So let's do that. Let's do 2.0 and 3.0, 3.0, and let's set the color to blue. And let's print out the area and the perimeters. And the sides actually as well. All right, let's run this. Okay, so there you go. So we got the area, which is 6. So 2 times 3 is 6. And the perimeter is 10. So if we add up all the sides, it equals to 10. And the number of sides is equal to 4. Let's create one more shape class. And let's do a circle this time. And this will also extend from the shape abstract class. And let's implement all of these methods. Now, same thing, in order for us to calculate the get area and get perimeter, we need to have a radius for a circle. So let's create a radius property. And let's do a constructor as well. So we're going to say in order to construct this circle object, you need to give us a radius. Now we can implement the get area method. To get the area for a circle is pi r squared. So math.pi, and we can multiply by radius, And the formula for get parameter is 2 pi r. So we can do 2 multiplied by math.pi multiplied by the radius. And the number of sides for a circle is 1. It's only one curved side for a circle. All right, let's test this circle out. So we're going to head over to main. I'm just going to copy this and just change up the object name. So instead of rectangle, it's going to be a circle this time. And we are creating a new circle object, which takes in a radius. So we can say this is 5.0. Let's set this to red. And let's replace these. All right, let's test this out. Okay, so this is our circle. So we can see the color was set to red, and this is the area, the perimeter, and the number of sides. Now the question you guys might have is, can we create an object from the circle class instead of from the shape class? Well, we can. So if I do this and run it, I'm going to get the same output. Now, why would we want to do this? Well, the only reason we may want to create an object directly from the circle class is if we had some extra methods that weren't part of the shape class. Now, one last thing I want to go over is a super keyword. So if I go back to my shape class, we had this constructor that was taking in this parameter, but we were never calling it. How can we call it? Well, one of the ways we could do it is if I go back to my circle class, I can create a new constructor. And we can say this circle, this constructor takes in a radius and also a color. So now in order to call the constructor directly from the circle class, we use this super keyword. And in the super, we're passing in this color. So the super is calling the constructor of the shape class. If I go to super, if I do Control B on it, it's going to take me directly to the constructor of the shape class. And if I go back to my circle class again, I can implement this constructor, and let's test this out. So we're here now. I can take in a new param, a color. So let's call this red, and I'm going to remove the set color here. Or let me just comment it out, and let's run this. All right, there you go. So I got red there. So super is a special keyword in Java which is used to call the constructor or even methods or properties of the parent class. So if I do super dot, I have access to get area, get perimeter, all of these three methods as well. All right, that's pretty much it for abstract classes. It's very important that we design or write our code in a way that makes it very easy to follow by abstracting out the details, which makes our design very modular. And what this means is that we can grow or add new features very easily. For example, we saw how quickly we were able to implement the circle class by extending from the abstract shape class that told us what we needed to implement in order to make it fully function. Abstract classes are used quite often. There's the calendar class that is part of Java util package, and this class is also an abstract class. So for example, if I'm trying to implement a Gregnon calendar object, and if I go to this class, and if I scroll a little bit on top, the class definition, you can see it's extending from the calendar class, and if I go into it, it is an abstract class. So abstract classes make design very neat. It avoids code duplication, and the biggest benefit that it gives us is that it makes our design very modular and structured. You may hear the term spaghetti code, which is basically code that is not structured properly and makes code very difficult to follow and read, and also makes it very hard to write new code or even implement new features. So writing code is not hard at all nowadays. What's hard is design, writing clean, well-structured code. I will have a separate video dedicated to different design patterns and things that we need to consider when architecting a new software project. Hopefully this video gave you guys a better understanding of abstract classes. To recap, we discussed what abstract classes were. They help make regular classes, and the way we create them is by adding this abstract keyword in front of the class. One important thing to note is we cannot directly instantiate from an abstract class. They are meant to be used only by regular classes. We also went over abstract methods, and these methods are created only inside abstract classes, and they can't have any implementation. These abstract methods are defined or implemented by the class that's extending from the abstract class. And the last thing we went over was the super keyword. So super keyword is a way of calling the constructor or the methods of the parent class. In this case, it was a shape class. In the next video, I will go over interfaces, which is a way of achieving complete abstraction. So if this video helped you guys out, please do subscribe to the channel, and I will see you all in the next video. Take care.